All right, so now what we're going to do is build up. So now we've talked about how to find the molar solubility or the concentration of different ions in solution. And now we're going to add on the idea that substances can be mixed. When you want a reaction to occur, you have to put two substances together, but they're both coming within liquids. So they are increasing the volume and becoming diluted. Dilution affects concentration because you have a new volume. So you must calculate a new concentration. So the key idea here is that the number of moles is going to stay the same before and after dilution. And so we can calculate the new concentration using the solution dilution equation, which is that M1V1 equals M2V2, where moles equals molarity times volume. So this is saying that the moles before dilution is equal to the moles after dilution. Now, instead of using M1V1 and M2V2, I'm going to use M initial and volume initial. And then I'll have molarity after dilution and volume of diluted solution. So that if I wanted to find the molarity of my diluted solution, I could do the molarity initially times the volume initially divided by the volume of my diluted solution. Sounds more confusing than it is. What we're going to look at is something like if 5 mils of 0.02 molar chloride is added to 15 mils of 0.02 molar bromide, what is the molarity of the chloride and the bromide ions in the mixture? Now, this is not a real scenario. This is a warm-up. So you never just add ions. You'd have to add ions as part of a solution, but we're just going to pretend so that we can do some simple calculations. So what you've got is you've got this 5 mils, right? 5 milliliters of a concentration of 0.020 molar for your chlorine. And then initially you have this bromide that contains 15 mils and it has 0.012 molar. And then what we're going to do is combine these together somehow so that there's a combined volume or a diluted volume of the 5 milliliters plus the 15 milliliters so that your diluted volume will be 20 milliliters. And we want to know what the concentration of the chloride and the bromide ions would be in this new solution. So to find the molar solubility or the concentration of the chloride ions in solution, you would take the molarity initially, times it by the volume initially, because that finds the number of moles of chloride in this solution, and then you divide it by the new diluted volume. So it's a fancy formula, but really what it does is calculate moles of chloride and then divides it by the new volume. So my molarity initially was 0.020. My volume initially was 5.0. And as long as your volume initially is in the same units as your volume diluted, it doesn't matter that they're in milliliters. So this original concentration is moles per liter, but then I'm doing a dilution with milliliters and milliliters, so those units actually just cancel out. So then I'm going to do 20.0 milliliters in my new diluted solution. So I'm taking my 0.02, timesing it by 5, and dividing it by 20, and my new concentration would be 0.005 moles per liter, or molarity. Or if you prefer, actually, because I should put a 0 on the end there, if you want to put it in scientific notation, it would be 5.0 to 2 sig figs, and then times 10 to the negative 4 molar. Oh, I added way too many zeros there, sorry. Let's just scratch that out. Powers of 10 is my Achilles heel. So 0.02 times 5 divided by 20 was 0.0050 to 2 sig figs moles per liter. Or we could write this as 5.0 times 10 to the negative 3. And again, you can use moles per liter or you can use molarity. Sorry about that. I should probably make this my last video. Okay, so if I want to do the same thing for the bromide ions, go for it. The original concentration of bromide is 0.012. original constant or volume is the 15, divided by the diluted volume, which is 20. And to 2 sig figs, I get 0.0090, or 9.0 times 10 to the negative 3. Awesome. All right, next question. So this one is more of a realistic solution or situation. You can't add ions, right? You have to add solutions together. So here I have ammonium bromide being mixed with ammonium sulfate. And what I want to do is find the concentration of all the ions present. So there's two things here. We have ammonium bromide, which is going to dissociate into ammonium ions and bromine ions. And then we also have this ammonium sulfate, which is going to dissociate, and again, both of these should be two-way arrows, into 2 ammonium ions and 1 sulfate, 2- anion. Okay, so what are they telling me? Well, they want me to find the concentration of all the ions, so ammonium, bromide, ammonium, and sulfate, when 25 mils of 0.360 molar ammonium bromide, so 0.360 molar bromide, is mixed with 0.160 molar ammonium sulfate. We have 25 mils of the ammonium bromide, and we have 75 mils of the ammonium sulfate. So I know that my volume diluted is going to be 100 milliliters. And I want to find the concentration of all the ions present in solution. So let's start with the ammonium bromide. Ammonium bromide is going to produce ammonia in a 1-to-1 ratio. So the concentration of ammonium is going to be the same as the concentration of ammonium bromide. So it's going to be that 0.360, and then we're going to do our solution dilution. So I'm going to times this by 25, and I'm going to divide by 100. So the concentration of ammonium in here, I'm trying to decide whether I put my equal sign there or down, all about how much space I have. So 0.36 times 25 divided by 100 gives me, to 3 sig figs, 0.0900 molar. I'm going to also do my concentration of bromide. You can always pause the video and give this a go. Again, it's in a 1-to-1 ratio, so the concentration of bromide is going to be 0.360 times the 25 divided by 100, so it's no different. So the concentration of bromide will be 0.0900 molar. Then we move over here. So we're going to find the concentration of ammonium ions in this solution. Now this is in a 1-to-2 molar ratio. So the concentration of the ammonium ions is going to be 2 times the 0.160. So you can put that into calculation. You could do 2 times 0.160, or you could just put in 0.320, up to you. But that's going to be my original molarity. And then I'm going to times that by the 75 mils and divide by 100. So the concentration of ammonium ions in my diluted solution will be 2 times 0.16 times 75 divided by 100, which gives me 0.240 to 2 sig figs. And then I'm going to do the concentration of sulfate. Now sulfate is back to a 1-to-1 ratio, so I'm going to use the 0.160 times the 75 divided by 100. Or I could just divide my other answer by 2. 0.16 times 75 divided by 100 equals 0.12. These can be done in different ways. I've also seen people figure out the concentration of the ammonium sulfate in my diluted solution and then do a 1-to-2 and a 1-to-1 ratio. It's kind of a choose your own adventure. Yeah, it's the beauty of life. There's more than one way of doing things. So if I wanted to state my overall concentrations, my concentration of bromide is the 0.0900 molar. The concentration of the sulfate is 0.12 molar. But then the concentration of the ammonium, everything's mixed together. So the overall concentration of ammonium is going to be the 0.0900 plus the 0.240, which is going to give me 0.330 molar. And for this one, I put the answers above, so let's just double check. Bromide is 0.0900, sulfate is 0.120, and ammonium is 0.330. Awesome. That is the end of solution dilution and the end of the first lesson.